Good morning or afternoon or evening or whenever it is that you're watching this. Welcome to the Intro to Energy. We're going to talk about thermal energy, chemical energy, exo-endothermic reactions, and their enthalpy. Hopefully we don't create any fires like this, but you never know. First we want to talk about the system and the surrounding. So the system is where stuff is actually going to be happening. Your chemical reactions, things where thermal reactions are happening, and the surrounding is the area around it that is interacting with the system. The surrounding can bring energy in or absorb the energy coming out, depending on the situation. Take a minute, identify the system and the surrounding in this situation. If you said that the green flask was the system and the box is the surrounding, then you were correct. Good job. Now take a minute to look at the picture and choose the correct options in the sentence. If we look at this arrow right here, heat is leaving the system and entering the surrounding area around the system. So what is energy? We're going to say it's the ability to do work. That's the most standard definition of energy. For our class, we're going to focus on two kinds of energy. We're going to talk about thermal energy, which is our energy due to the motion of atoms. When atoms and molecules start moving because they've absorbed enough heat to start gaining energy to move, they start colliding and forming reactions, which then leads us to chemical energy, which is when we have these bonds between atoms that are formed or broken depending on the situation, and that leads energy to be absorbed or released. So Sir Isaac Newton was one of the founders of our ideas of energy, and he came up with this idea of the conservation of energy. And energy can't be created, and it can't be destroyed. It can only be transferred from system to system or within the system. If we look at this down here, we can see that this ball has energy. It knocks 1, 2, 3, 4 balls down. That energy has to go somewhere, so it gets absorbed by this last ball, which is why it goes shooting off the end. And it keeps happening because the energy just keeps getting transferred. So think about it. We have a law of conservation of energy, and previously we've talked about a law of conservation of mass. How are they different? Well, law of conservation of energy states that energy can't be created or destroyed, only transferred. And law of conservation of mass states that mass can't be created or destroyed, only transferred. So it's the same idea, just two different versions of it. So now, if energy can't be created, it can't be destroyed, then when you die, what happens to the energy that's in your body? If you're a scientist, many people believe that that energy gets absorbed by bacteria and fungus and other decomposers, and they absorb what was your energy, all of the carbon in your body, and they use it to procreate themselves. And so it's this huge cycle of energy being transferred. So now watch this video, answer the questions about energy, and come back to this video. Now think back to biology. We have concentrations of things that diffuse. Do they diffuse from high to low or low to high? If we look at these two GIFs, this concentration at the top is very high and it's floating downwards to a lower concentration. Over here, we start off with dots that are very clustered together, indicating a high concentration, and they're floating down to the other side of the tank where the concentration is lower. So things diffuse from high to low. And you're like, why are you bringing this up? This is chemistry, not biology. Because heat transfers from a high temperature to a low temperature every single time. When your hot coffee is on the table, and it gets cold, it's because all of its heat energy was transferred into the environment. We have the red block and the blue block. Red block's hot, blue block is cold. When you bring them together, that heat from the red block transfers into the blue block and they come to an equilibrium temperature. They come to the same temperature at the end. So take a minute, indicate the flow of heat in these images with an arrow, or just indicate with yourself, just pointing from area to area. So the fire goes from the log to the pot, and then the sun heats up the house, and if I have a hot temperature, it's going to transfer its energy to a cold temperature. So wait a minute, if things go from hot to cold every time, how does the inside of the refrigerator stay cold? Well, watch this video, answer the question in your notes, and if you want to talk about it, post a channel about it, post a comment about it in the channel where it says post. So now we're going to talk about enthalpy. So the simple, not complicated, low-level chemistry definition of energy is heat. The total heat between the system and the surrounding. And since heat starts with H, we're going to use H to symbolize enthalpy. Even though enthalpy starts with an E, we have these other E words that we have to talk about, and that's why it's not E. It's H for heat. Triangle means change, if you forgot. So delta H, triangle is delta. Delta H is the change in enthalpy. For an endothermic reaction, it's positive. For an exothermic reaction, it's negative. You're like, Miss, I don't know what those words mean. Bam! Exothermic. Exo sounds like exit. Energy is exiting the system, meaning energy is being released from the system into the environment, such as a combustion reaction, like an explosion, or a fire is releasing heat energy into the environment and from the system. Again, this delta H is negative, and you can click on this link or go to this link to watch an exothermic reaction. And we'll talk about making bonds in the next video. In the endothermic reaction, energy is entering the system, the opposite of the exothermic. So the system is absorbing the energy from the surrounding, and then the reaction occurs. And so, for example, photosynthesis. The plant takes in the sunlight to create energy. It's also, you need energy to break bonds. And again, our enthalpy is positive because we are absorbing energy into the system. I'm not sure if this link works. You can try it if you want. If not, you can just type into YouTube endothermic reactions and there will be a couple of options for you to watch. Take a minute. Identify the exo and endothermic reactions in these images. So as we said, fire is an exothermic reaction because energy is coming off the flame. And the cesium over here that is blowing up everywhere is releasing lots of energy. So that is also exothermic. When we, cook the egg is absorbing that heat energy so that it can be cooked. And so absorbing is endothermic. If we have a hot day at the ocean, the sun is beating down on the water is absorbing that energy, those molecules are getting lots of energy, they're getting further and further apart, and then they enter the gas phase. And so they absorb energy in order to evaporate. And we talked a little bit about photosynthesis, and take a minute, look at photosynthesis, which happens in plants. and cellular respiration, which is what happens in our mitochondria when we break down sugar to make ATP energy. And if you look, they're the opposite of each other. We have carbon dioxide, water, and energy going into the plant and creating sugar and oxygen. And then our mitochondria takes in that sugar and oxygen and produces carbon dioxide, water, and our fabulous ATP energy. So it releases energy like an exothermic reaction. And why does that happen? We're going to talk about that in the next video.